So we did a wirelessly controlled motorized mountain board. We have a control coming from here. It's controlled by a pick. It sends wirelessly the signals down into our Arduino at the bottom, and that takes our values from flex sensors that we have in the wrist and converts it to the servo. So you can see this is the brake, and when he bends his wrist down, it pulls it up.
Yeah. Here's the brake servo. It doesn't take a whole lot to get this thing to go from idle to full gas. It's a very limited throw on the carb here.
The wrist control defaults to showing your RPMs and speed. When you press this button, it will switch it over to show the bend sensor value so that you can diagnose how it's working. This button here is a horn, and the middle button here kills it. So while you're running the board, if you're having engine difficulties and you're freaking out because it's piling on smoke, this will efficiently kill it right away by activating a relay in here that just grounds the engine.
This motor, it comes from the factory with this multi-use output shaft that has a hex, 1-inch hex, but also a 4-groove pulley shaft. So we fabricated a pulley to use that same profile and found a Gates belt that would fit it, then made a motor mount with adjustable slots to set the tension. Once you go from belt drive, it turns this welded bike sprocket, which obviously is on a bike chain, and we have 2 repurposed bike derailleurs setting the chain tension on both drive sides, and then a repurposed bike sprocket that's on custom plates bolted to the wheels as the final drive.
We put our brake servo on a separate battery source than our Arduino and our other servo. We figured, one, because it was high torque, so it requires a lot of current, but also you want a separate battery source for your brakes.
The 3D printed enclosure on the bottom houses the battery pack for the servo, an Arduino Uno controller for these 2 servos, the XB wireless, and the battery pack for the Arduino control circuit.
Hit the kill switch.